A huge experiment gives a first glimpse into the internal structure of neutrons, of all things. And you would think that we would already know quite a lot about neutrons, but the reality is not that. Neutrons are notoriously difficult to detect because they're neutral and don't interact as much as electrons and protons do, and we know even less about what's going on inside of them. Now, the image that you're looking at here is not the inside of a neutron. That is a sort of artist rendering of what they think that might look like, but we've been trying for about 10 years to find out what's going on inside of neutrons, and even built this large machine called the Central Neutron Detector at the US Department of Energy's Thomas Jefferson National Accelerator Facility, and it's trying to describe a quantum map of the neutron's engine, or the elementary particles that compose a neutron themselves. I'm going to skip ahead just a little bit here. This is the Central Neutron Detector. This is how big of a machine. You can see the size of those signs being printed out on a regular 8x10 piece of paper. So this is several times larger than a single person, and this is the size and complexity of machine that we need to actually be able to detect even a single neutron, which is kind of wild. And what this seeks to do is not like radically revolutionize neutrons, or to truly see inside of them as the art indicates here, but rather to make a quantum map of the quarks that compose a neutron and how they're bound to each other. So for example, you can see a proton, we have two up quarks tied to a down quark, and for a neutron, we have an up quark tied to two down quarks. And quarks are, unfortunately, anything but simple. Describing quark trios in such a fashion makes them sound as organized as eggs in a carton. In truth, they are anything but that. They're a chaotic storm of particles and antiparticles existing and not existing inside of a quantum competition with other particles. And yeah, so what we're doing right now is trying to figure out more about this structure. We want to figure out what makes neutrons work, and we're a long way from getting a full answer. The experiment has just now started to work, so it'll probably be a while before we get any sort of hard answers about the exact internal structure of a neutron.